AP Calculus AB. Solve the differential equation number 2. So the question will be presented to you this way on the exam, probably on a multiple choice question. And I just want you to know where to go with this and what are they asking you to do. First thing I would do is I would write it in integral form. So I would write it y is equal to the indefinite integral of 10x squared over, and just to give you an idea of where I'm going with this, I just rewrite it like this: 1 plus x cubed to the 1/2 power. And it'll make sense in a second why I do it this way, but I'm going to start looking at this. Now what I'm going to do is here, as I look at this, I'm looking at this top part and I'm thinking, is this piece up here part of the derivative of this inner piece here? And I think that it is. So what I'm going to do is this: I'm going to use U-substitution, and I'm going to say let U equal 1 plus x cubed. And then I'm going to go ahead and take the derivative of that, which is du dx, right? U in terms of x would be 3x squared, wouldn't it? Now what I'm going to do is, this is my whole goal here. My whole goal here is that I want to get everything in terms of u. So right now I have 1 plus x cubed in terms of u, so I can put a u in here, right? But then I have a dx here. So what I want to do is I want to figure out what is dx. And dx, if you look at it, is du, isn't it, over 3x squared. And I'm hoping that you see that when I put this in, that this x squared right here is going to cancel this x squared up here. So this is going to work out pretty good. So let me start to substitute some stuff in terms of u. So y is equal to the indefinite integral 10x squared all over, remember, u to the 1. You know what I'm going to do here if you don't care? I'm going to, let me see if you can see this. I'm going to write this as 10x squared. This down here is to the 1/2. I can bring it up to the negative 1/2, right? So I'm going to put u to the negative 1/2. And instead of dx, right, I have dx here, I'm going to put it in terms of u. So most things will be in terms of u. So I'll have du over 3x squared. Now what I'm hoping is that you can see some of this starting to come together. What we're looking for is f of u du. Right? So right now we have all these x's. But if you look, these are all factors. Right? And just to make a little picture here for you to see, these are the numerators, this is a denominator. Well, this x squared right here cancels this x squared down here, doesn't it? Can you see that? So what I'm going to do is I'm going to go ahead and cancel those out. And then what I'm going to do is I know that I can factor out any constant multiple, and there's one of 10 thirds. There's a 10 up here and a 3 down here. So I'm going to say 10 thirds times u to the negative 1/2 du. I hope that you can see now we have that dream situation, because if we get this in f of u du form, we're in great shape. So that's where we are right now. If we have this, now we can start doing our integration. So I'm going to go from here. I'm going to start to integrate. So I'm going to go ahead and integrate here. Remember, when you start to integrate, you're going to take your integration bars down. Here you're saying you're going to integrate, and now I'm going to go ahead and do that. So the 10 thirds is the constant multiple. What I'm going to do here is, right, it's this plus 1, isn't it, over that thing plus 1. So we'll give us u to the 1/2 over 1/2. Hopefully you can see that, plus c. I'm integrating now. Remember, this is a complex fraction, so this 1/2 comes up as its reciprocal. So we have 2 over 1 times 10 over 3, which is 20 over 3, don't we? U to the 1/2 plus c. Here's a mistake that some people make. They forget to resubstitute. So we're going to go ahead and resubstitute here. So as I do my resubstitution, just remember what we had, that what we took as our u value, and we have 20 over 3 times 1 plus x cubed to the 1/2 power plus c. And that's the solution for our differential equation. How could you check this? You could check this by differentiation. Check by differentiation. And I'm not saying that you should excuse me, do that 100 times over, but occasionally you should check and see if it worked out right. On the AP exam, there probably won't be time to do much of that, but there's my answer. You're going to see this, I promise. Mostly you're going to see it, I believe, on the multiple choice. You could see it someplace on the free response, but we need to pick up all the points that we can get. So I'm hoping this is helpful to you. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. Thanks so much for all the support, you guys. Appreciate it.